I'm Adam Paul from the band Indifferent Engine, and I'm going to talk to you about the Janky tape echo. So the Janky tape echo, it's a real tape echo pedal built from a cassette player, some 3D printed parts and some custom electronics. It creates a glitchy, horrible, but hopefully musical echo sound that you can use to add atmosphere to guitars, vocals, synthesizers, or anything else that you want to plug into it. Everything about the pedal is open source, so the schematics, the 3D printer files, the source CAD files, the PCB files, everything is available for free online. If you follow the link in the description, it will take you to a page where you can get that stuff. We also provide some very detailed instructions that not only show you how to make one of these pedals, but also goes into some of the theory behind how it works, and it tries to explain why the electronics are the way that they are. We don't sell these pedals assembled. However, we do have a merch store. Indifferent Engine is a band, so we have a merch store, and we will be offering some PCBs for sale on there. So if you don't want to make your own PCBs, you can grab one from us. There may be other components that we'll be selling, and potentially we might offer kits for these soon. If you're interested in kits, then you can join the mailing list on our website to get informed about if and when that's going to be happening. And if you're building one of these completely yourself, but you still want to show us a little bit of support to help keep us out playing some shows, then we do sell some t-shirts and things like that on our website that you can grab, or you can just go and check out our music. Okay, so to get started, I'm just going to give you a quick demo of the pedal. This is the clean sound we're using. I'm just going straight into the clean channel on the Rockever amp, and so if I switch the pedal in, so I've got it set quite clean here. I've got the gain rolled down, and we're at quite a slow setting. I can slow it down further to get a longer delay. Some of the best sounds are when you have the tape speed quite slow like this, and then just bring the gain up a bit to drive the tape a bit harder. It becomes very kind of crunchy and washy. to switch to the driven channel now so you can see what that sounds like. So this is the drive sound. So it's just a little bit of crunch added by the amp. And so then if I switch in the echo, And some of my favorite things to do is to set the feedback quite far up with a slow time and quite a driven sound, and then just kind of violin chords in like. So I'm just going to give you a quick rundown of the controls on the Janky and what kind of features the Janky has. Obviously the Janky is a real tape echo, so it uses cassette tape to create its echo effect. And on the front panel here on this red unit, you can see that there's a time control, just as there is on any echo effect. But the difference with this being a tape echo is that the way that echo time is controlled is by speeding up and slowing down the motor in the tape machine. And that's quite interesting to look at, because it has implications for the tone of the machine. Because depending on how fast the tape is running, it's going to change the equalization that you get from that tape. So when the tape is running quickly, you're going to get more high-end detail, so you're going to get more like brightness. It's going to come out as brightness in the sound. And when the tape is running slowly, it's going to be darker. And so one of the features that we have on this machine, just above the time control, is this toggle switch. And what that lets you do is select two different read heads that are in this machine. And the purpose of that is that the heads are in different positions. So one of them is sort of over here somewhere next to the right head, and the other one is over here much further away. And that means that you can get a wider range of delay times, but it also means that you can get the same delay time but at a different tape speed. And that means you can get that same echo time but with a different equalization, a different brightness that you're going to get. But besides brightness, there's actually other things that the tape speed influences as well. You're going to get a different sort of level of artifacts at lower tape speeds compared to higher tape speeds. So at low speed, the motor's going to struggle to keep the tape running evenly. The tape is going to be more prone to catching and more prone to the friction that's present in the physical tape path that the tape is following. And so that's going to come out as more wow and flutter and other kind of interesting artifacts. So if you want a particularly clean echo sound, then you want to run the motor faster to get rid of those things. But if you want all that interesting textural stuff, then you want to run the motor slower. And so it's useful to be able to choose which head you're using so that you can choose what speed the tape's going to be running at to get those different tonalities and those different artifacts. The next thing is obviously it has a feedback control like any analog delay would have. This is controlling how much of the echo wet sound is being fed back to the input to give you more repeats. So if I set that all the way down, and I've stomped this on, you're just going to get that one repeat. But as you turn this up, you're going to start getting more repeats. And this will go all the way into crazy oscillation if you... some really horrible, nasty sounds if you really wanted to. Some really interesting textural sounds, which is quite cool. Then we come to there's a Jank control, and what this does, when it's all the way off, it doesn't do anything. But as you turn this up, it starts to make the motor run unevenly. So if I have this all the way down, and just give us a little feedback. More feedback. So it sounds quite stable. It's quite a nice even repeats. There's not a huge amount of artifacts in there, but as I turn up this Jank control, you can hear now the pitch is jumping about. It becomes really noticeable when you hold a chord over the repeat. And I mean, it will do something really crazy if you turn it all the way. You can hear then the motor is starting and stopping slightly. And you'll get slightly different sounds at different places on the range of this control. I usually like to have it set quite low, just to add a little bit of chorusing effect when I'm holding chords. I quite like it when you, let's turn it up a little more. I quite like it when you kind of violin in chords. And you get that kind of flutter happening from the Jank control being on just a little bit. It quite makes it sound like kind of like an analog synth. Yeah, so I really like that. That's something that you can play with. There's a gain control. What the gain control does, as you probably guessed, is it allows you to boost the signal up. And it does that before it goes to tape. So if I have the gain control quite low like it is here, it's going to be very clean sounding. We're getting a bit of drive mainly from the amplifier, but if I crank this, it's now very crunchy. And that's because we're now boosting that signal up and really slamming the tape with it, and that gives you tape saturation, which is quite a pleasing kind of overdrive sound that you're going to get from that tape. So I'll turn that down a bit. The tone control is next. So the tone control, that's just a low-pass filter, and at its brightest, you can hear even the noise is just brightened up there. You're going to get quite bright repeats, and then as you turn this down, you're going to get something much darker. Turn it all the way down. So it allows you to kind of to control how much brightness there is. It does also allow you to remove some of the noise. There are several features that we've put into this tape echo to deal with the noise that comes from this machine, because even just stomping this on and off, you can hear that's the clean signal right here. Like, it's very, very free of noise. There's no hissing. There's a very slight hissing coming from the amplifier, but there's nothing really very noticeable. As soon as you turn this on, you get quite a lot of noise, and you can probably hear in there, some of the noise relates to the motor. If I change the motor speed, you can actually hear the noise change pitch, because that's noise that's coming from the motor. And the other noise that you can hear if I turn the tone up, you hear it start to come in, is that fizzing. That's called tape hiss. So that's noise that's being introduced by the tape itself. And you're always going to have some of that. It's difficult to completely get rid of it. But there are several features that we've implemented in this machine to help with that. So the first is that we use a technique called pre-emphasis de-emphasis, which is where, because the tape hiss is high frequency in nature, it's a high frequency noise signal, what we can do is we boost the high end on the way onto tape, and then when the signal comes off of tape, we then cut by roughly the same amount. And so then you end up with the guitar signal being the same overall, that you end up back at a neutral position because you've boosted the high end of the guitar signal, then cut it again. You end up with the same signal that you originally had, more or less. But because the noise was introduced after the boost happened, you only apply the cut to the noise. So you end up with the same guitar signal, but the noise has been cut. And so the amount of pre-emphasis, de-emphasis can be configured in these machines to a certain extent. We use a Baxendorf filter on the way in, which has a couple of trimmers that you can adjust to adjust how much boost you want and how much cut you want, both in terms of treble and bass. And then on the way off the machine, there's a Janky filter stage, which then acts as a low pass, an active low pass that then is meant to take off that high end to get you back to roughly a neutral position. And you can, by changing part selection, adjust that filter as well, as part of building the machine. But this low pass filter that we've got on here, this comes after that Janky, so you can actually roll more of the high end off to get rid of more of that hiss. And the way that I typically set these machines up is that I actually leave quite a bit of hiss in there. I don't boost the high end too much. I know Tom, when he tunes these, this is one that was tuned up by Tom, he likes to boost the high end as much as possible so that it gets rid of much tape hiss on the way out. And he sets his Janky quite aggressive to really get rid of that tape hiss. But I like leaving some of that tape hiss in so that I can use it as a kind of musical textural thing, because I quite like noisy sounds. So it's something that the user, as part of building the machine, can kind of adjust that stuff to a certain extent. And then beyond that, we've got a level control on here, which is actually a mix control. It's completely dry all the way to completely wet. The cool thing with that is that if you set the feedback all the way down, so you're just getting that one repeat, you can then set this all the way wet, and you can send tracks through this from your DAW and just get like a tape colored track of pretty much anything that you want to send through it, which is kind of quite interesting, from a production point of view, something that you can do. Probably the last thing worth talking about is just the way the switching works. So it doesn't have a stomp switch on here like a normal pedal would. With this being 3D printed, we figured that that's not ideal to have people stamping on this. So instead we've included a remote jack like what a amplifier would have, so that you can plug in an amp switching dealy bob, a little foot switch like this. This expects a push to make momentary foot switch, so you can just go and buy one of those from anywhere online that sells that kind of thing. We make our own ones where we buy the little momentary switches off the internet, and then we 3D print a nice soft flexi pad that goes on the top with our logo on, just because it looks quite neat. We might sell some of these on our merch store for people that want to have a branded one. So I'm just going to talk a little bit about what's involved in building one of these machines. It's not your standard DIY pedal build, right? If you've no experience of building pedals at all, it might be best to start with something else that's a little easier, like a fuzz pedal or something like that, just so you can kind of get used to soldering parts in and all that kind of stuff. It's not exactly a paint by numbers kind of build. Like often if you buy pedal kits, it's very much like put this part in this place and you just follow the steps. You don't really need to know anything about what you're doing. You can just kind of paint by numbers. It's not quite so easy to do that with these machines. First of all, you need to 3D print all the enclosure parts, right? All this black and red plastic stuff, that's all 3D printed. So you need to be able to 3D print that stuff, and you have to be able to print it to a good quality level. Like obviously the parts are still going to come off the printer looking like 3D printed parts, but you need dimensional accuracy. You need things. There are some quite small parts in this machine that need to be printed with a good quality level. There may also be a minimal amount of post-processing, just kind of removing zits from the print and just like smoothing edges very lightly with sandpaper, just to get as little friction in the tape path as possible. So the little rims that the reels sit on, for example, often we'll sand the top of those lightly and use a little bit of lubrication just to make sure that the reel can spin freely, so it's not going to be impeding the tape, so that you get as clean a tape path as possible and get as fewer artifacts as possible. Because even when these machines are really tuned up, they are quite janky and glitchy, right? There's quite a lot of artifacts, and so starting from a place where you've minimized that is usually good, and then you can kind of dial it back in with the jank control. Yeah, there's a fair amount of that stuff that's needed. You have to be able to install heatset inserts into the 3D printed plastic, which is pretty easy, but it's another thing that if you haven't done it before, might be a little bit intimidating to a new builder. And what those are is they're little brass threaded inserts that you use a soldering iron to press into the plastic. And that's how we bolt all the various things together. So most of the places where you see these bolts that are holding things together, they're going into those inserts. And the reason why you do that is that it makes the part mechanically much stronger, and it makes the part something that can be serviced. So we can unbolt these bolts, take the whole machine apart, work on it, and then put it all back together again. And in doing that, we're not going to be stripping plastic out every time we take the bolts out, because otherwise eventually, after 2 or 3 services, you're going to have stripped the holes the bolts go in, and they're not going to want to go back in. Whereas if it's a threaded insert, they're very hard wearing. That's not going to happen. And these machines, they need to be serviced. You're going to need to open it up at some point and replace the tape loop, because the loops, they wear out. They're kind of, you think of them kind of like guitar strings, right? Eventually, no matter how well that string has been put on the guitar, it's going to wear out, or it's going to snap, or something's going to happen, and you're going to have to put a new string on there. Exactly the same with the tape machine. You need to replace the tape loops. There's other things that may eventually need doing as well, like the belts that are in these tape machines might need replacing at some point, so we're going to need to get the back of the machine off to replace the belt. Incidentally, we actually have an STL file, a 3D printing file for these machines for replacement belts. So if you can print flexible filament, you can actually print a new belt for these machines as well. So you should be able to keep them running so long as you've got the know-how to take it apart and do those things, or you're willing to try. There's also things like just being able to lubricate the gears and things like that in the tape machine will probably need doing at some point to keep it running at its best. So then we come to the electronics. The electronics should be reasonably straightforward. There's not really any exotic components. If you're used to pedal building, then probably the only unusual things are going to be the Arduino, because you probably haven't done digital electronics before. But in this case, it's quite simple, because we give you some pretty straightforward instructions of how to just copy the software onto that Arduino using your PC, and then you just solder that Arduino into the circuit and it should just work. But it's another thing that you might not have done before, that you need to pay attention to. The other is cassette heads. There are cassette heads, obviously, that we need to solder wires to and to connect up to this machine, and that can be a little bit tricky. They're a little bit tricky to kind of solder the wires to the back of the heads, but it should still be something that's perfectly manageable for anyone with a bit of experience with a soldering iron. But it's something that you have to pay attention to. And then lastly, with the electronics, is that we have to use something to allow us to disconnect all the wiring at some point, because as part of, as I said, servicing these machines, we need to be able to completely disassemble them. And so all the off-board wiring, and there's quite a lot in this tape machine, all of that is done with headers. And we use JST-XH headers, and so you need to be able to crimp those kinds of headers. Again, we give you instructions on how to do that, but if you've never done it before, it's another thing you're going to have to get the tool for and learn how to do. You can't just solder the wires into the boards on these machines. I mean, obviously you can do that, but it just means that you're not going to be able to disassemble that machine. And, you know, in a month's time, when you need to put a new loop in this, you're stuffed because you can't get the electronics out of the way to get at the machine to do what you need to do. So yeah, you really need to figure out a way to do that without. And if you don't use JST-XH headers, there are other kinds of headers you can use. The easiest ones to use as a beginner would be something like screw terminals. So you can install screw terminals in place of the JST headers and use those. We find they're not as reliable. The wires tend to come loose from the screws, or the wires tend to break at the point where they go into the terminals and that kind of thing. But they are very easy to install, and they're very easy to disconnect the wires from. So for your first attempt at building one of these machines, it would be perfectly acceptable to use screw terminals. And that's pretty much it for the electronics. There's some like complicated things when you get into the nuts and bolts of how they work, especially in order to write to tape, you need to use a technique called AC bias, which is where you're generating a big clean sine wave that's at quite a high voltage that gets added to the audio signal. But you can just kind of install the components the way that we tell you to, and that should just work. So you don't really need to worry too much about how that works or why it's done, but you will need to pay attention to the part choices that we specify in terms of ratings. Like the capacitors, for example, they have to be a very specific type of capacitor. Some of the capacitors have to be multi-layer ceramic capacitors, or the oscillator isn't going to work. And some of them have to have high voltage ratings. Like if you don't put 100 volt DC rated capacitors in the oscillator, your oscillator is not going to work. Your tape machine isn't going to work. So some of that stuff you have to be a little careful about. We do remind people in the instructions that this is the case, and we make it very clear which parts are the ones that need to have the high ratings. But it's something you just have to remember to do. Otherwise, yeah, your machine's not going to work. And that's pretty much it for the electronics. I think that there's some normal audio circuitry that you'll have seen before if you've built pedals. We use easy to find op amps like TLO72s and that kind of stuff. So there's no real exotic parts in there. When it comes to the cassette heads, you can find those online quite easily. You need to find yourself two stereo read-write heads. You can use mono heads, and even 4-track heads will work, but we found that that stereo heads are the best match for this machine. You will also need to find yourself an active erase head. You cannot use, now erase heads, they come in two types. They come as passive, which is basically just a magnet, and they come as active, which is an inductor, which is what we use in these machines. And you have to use an active head. You can't put a passive erase head into these machines, it won't work. The reason for that is that active head is used as part of the bias oscillator circuitry to actually generate the bias signal that allows you to write to tape. So if you don't have an active head, then your electronics isn't going to work. So that's something you do have to find. At the moment, though, they're still quite easy to find online. There are a few places that you can buy these, and they're not expensive. Tape heads in general are going to cost you a couple of quid each. They're not particularly expensive or hard to find. But one problem though with heads is that they're not standardized in terms of their dimensions, their inductance and coil resistance, and most importantly their mounting hole positions. Right, they're all different sizes, and so we couldn't design a machine that would just accept any head. So what we've done is we've made our own little what we call head adapters. So those are adapters that go into this machine that go between the head and the rest of the machine that allows you to mount that specific head into that machine. And we make these for heads that we install into the machine, so we'll probably share at least one or two of those as part of the open source project. But if you try to use a head that's not one that there is already an adapter for, you'll need to make an adapter. We're going to give some instructions of how to do that with free CAD software. It is pretty straightforward to do. It's not difficult. You do need something you can measure distances with on a small scale, like a set of calipers or something like that. But it's actually quite straightforward to make head adapters. And as we go, we're going to potentially release more head adapters so it becomes easier for people to find heads that already have adapters that you can use. There is further problems with that in that different 3D printers will print things at slightly different dimensions. Different filaments will shrink by different amounts, and the tolerances in these machines are quite tight. The kinds of distances we're talking about are very, very small. It's fractions of a millimeter. So even if we give you one of our head adapters, it might not be ideal. And so it might not quite be the right height. The mounting hole positions might not be quite exactly in the right places. So one of the things that we do is we've actually designed our head adapters so that they have little springs in, so that you can actually lift the head by just loosening the bolts a little. And that gives you two things. One is it gives you an azimuth control, which I'm not going to go into now, but it's a way of changing the attack angle on the head as it meets the tape to change the equalization of that head, the sound of that data that's being written to the tape. But it actually allows you to change the height of the head as well very slightly, so you can kind of compensate for different differences in different filaments and different printers that are printing that same head adapter. But yeah, it's still gonna be a bit of tinkering in order to make sure those heads are in the right positions for your machine. It's not something that's you can just stick a head in there and it's going to work great first time. There's probably going to be a little bit of tinkering involved in making sure all the heads are lined up properly. And so it's just another factor that makes building these machines a little tricky. And then obviously you have to be able to make a tape loop. Like the loops that are in these machines are made from cassette tape, but you actually have to make those. You have to open up a cassette, take the tape out, run it around the machine, and then take tape and stick the tape loop together. And you have to do that cleanly enough that the tape isn't going to jam, it's not going to stick on the heads, and it's going to have the correct tension for the machine. So that because if you get the tape loop is too tight or it's too loose, you're going to get snagging and jamming, or that tape loop might just shred. It's a bit of an art making tape loops. So that's something that's going to take a bit of practice, and it's probably going to take you a few attempts at making loops before you get ones that are perfectly stable and reliable. There's also things like where you source your cassette tape from. One of the things you notice after you've been making loops for a while is not all cassette tape is born equal. You get tapes of different thickness, different coating types, and all of these things contribute to how reliable that tape loop is going to be, how long it's going to last, and what it's going to sound like. So we find that cassettes that were designed for use in computers tend to have the thickest, best tape that's most reliable, because those machines, they were using cassettes to read and write data to the tape, and the machine would often want to rewrite the same bits of tape over and over. So the tape is much thicker because it has to be able to survive being run over the heads many more times than a standard audio cassette would. And the coating is much better it's much more resilient, so it can accept more reads and writes before the coating wears out. So those tapes tend to be the best. So we have a stack of those that we use for making loops for these machines. But the problem with that is they're becoming rare and expensive now. Obviously they're not manufactured anymore, so it's only new old stock tapes that you can get. And so yeah, they're becoming expensive. So we have a little supply of those that we keep, so that we should have enough to last us for making loops, but you might find those are getting trickier to find. You can use any cassette tape if you want, it's just that you're going to find yourself needing to replace loops more often, and you're going to find yourself occasionally getting jams where the tape actually jams in the machine, where it sticks itself to the front of the head, or it gets tangled in the pinch roller or something, and then you're going to have to take the lid off the machine, cut that away and put a new loop in. Or sometimes you can just kind of like prod the loop with a Allen key or something and get it to unstick, and then it will run for another hour again perfectly fine, but it's finicky. If you want to use these machines the way we do, where we use them in our live rigs, then you're going to need to have a really reliable loop in there, so you know that when you stamp the machine on, the loop's going to run freely and it's going to last you, and it's not going to break down randomly in the middle of a show. And for that, you're going to need to find good quality cassette tape. One of the other things you have to pay attention to when building these machines is the mechanical parts. There are tape guides in these machines that we make. We make them out of short lengths of steel rod, and we put some bearings on there, some shielded ball bearings. Those parts are easy to find online. They're not difficult to find, they're not even expensive, they're very cheap, they're very easy to source, but you do need to cut that steel rod to lengths, which means you need either to get some calipers or something to measure out the lengths, and then some strong pliers to just cut through that steel. You can do it with just a standard pair of pliers that you can just use in your hands, so you can cut through steel with those. Or you need to find a supplier that will cut that steel rod to length for you. That's what we do these days, because we're building a whole bunch of these. We just tend to go to a supplier who will cut those steel rods to length and deliver them to us already pre-cut. So you can do that. And again, it's not massively expensive. It's more expensive than doing it yourself, but it's not ruinously expensive. So it is something that you can just go to a supplier. There'll be someone local in your country that will do that for you. It's quite an easy service to find. But again, you've still got to then get the ball bearings onto the rod, and there's a bit that can be a bit tricky, and then get those rods installed into the 3D printed plastic. It's just more stuff that you have to do as part of the assembly that isn't stuff you normally have to do building an effects pedal. So it's something you have to kind of pay attention to. Another thing that you have to do is EM shielding. So we paint the inside of these enclosures with conductive paint, because obviously with this being plastic, it doesn't offer any kind of noise shielding. So we take conductive paint and we paint the insides of the enclosure with it, and then that's then grounded to the electronics to offer noise shielding. It's not something you have to do, but it does improve the noise performance of the machine. So it's something we recommend, and that's, again, it's another step you have to do that isn't something you normally have to do when building pedals. Probably the last thing I'll just talk about is the reels. You do need reels from a reel-to-reel cassette. We actually manufacture our own reels, and we plan on selling those on our merch store. So if you come to us to get a PCB, you can grab a set of reels while you're at it. But if you want to find your own reels, then you need a reel-to-reel cassette. And those are becoming a little bit expensive and a little bit rare. You might end up paying 10, 15 quid for a cassette just to get the reels out of it. What we will say is any reel-to-reel cassette should work fine. They're all the same size, so you can put any reels from those cassettes in there, but you do need to find these kinds of reels from somewhere. You can also 3D, I've seen people 3D print these reels before. So my problem with that is that you probably wouldn't get very smooth action of the reel in the machine, probably because the 3D print, the surfaces tend to not be completely smooth. You'll probably find that when that's put onto the rim on the machine, that's going to catch a little and not be perfectly smooth. But you might be able to get that to work. There's probably other ways you can do it. If you have a laser machine or a CNC or something, you can make reels that way as well. But that's another hurdle you have to overcome to make these machines. So yeah, it's something you should be aware of. So I think that's everything that I wanted to talk about with these machines. I think if you're interested in building one of these, then you should check out the build instructions, have a good read through there and see what's involved. And then all the files that you need, as I said before, they're open source, so they're freely available on the internet. And if you want to get a PCB or something like that, if you don't want to go and make your own PCBs, then you can grab a PCB from our merch store.